A self-driving car has to keep doing 4 things at once: work out where it is, understand what is around it, estimate what may happen next, and choose a safe move. That is the part people notice first. The useful question is what it tells us about how AI agents run autonomous vehicles, the hidden system behind self-driving cars, and what the system is actually doing. Night shifters. Good evening. I am Night Shift Engineer, checking in from a data center where every blinking light is either routine maintenance or the beginning of a very long night. Let us start simple, then work our way toward the detail the headline left in the server closet. A self-driving car has to keep doing 4 things at once: work out where it is, understand what is around it, estimate what may happen next, and choose a safe move. It has to do that while lane markings are worn, a cyclist changes their mind, and a delivery truck parks exactly where nobody wants it. So when people ask whether the car has one big AI brain, the useful answer is, not really. It is closer to a stack of specialized jobs with very little time for a committee meeting. Tonight, we are following that stack from sensor to steering wheel and looking at the places where the real engineering gets difficult. That is the frame for the rest of the episode. Separate the jobs, then look at the handoffs. A reliable road system is mostly built out of honest handoffs. Here is the simple version. Imagine a careful new driver with excellent eyesight, no phone, and a backpack full of maps. First, they look around. Then they decide what every nearby thing probably is. Then they make a short list of what those things might do next. Finally, they choose a path that stays inside the road, follows the rules, and gives everybody room. An automated vehicle does a version of that loop many times per second. The labels change between companies, but the pattern is familiar. Localization, perception, prediction, planning, and control. Calling all of that one agent is tidy for a thumbnail. Calling it one agent in an engineering review is how somebody ends up asking the wrong question. The useful trick is to picture the loop, not a cartoon brain. Each stage gives the next stage a better, but never perfect, starting point. The first hard problem is sensing. Cameras are good at visual detail. Lane paint, signal color, construction signs, the human talent for putting a cardboard sofa on the curb. LiDAR measures distance by timing light. Radar is useful for distance and relative motion, including in weather where a camera has a rougher day. Those sensors do not hand the car a finished answer. They produce different imperfect measurements at different ranges and times. Software has to align them and decide how much confidence to place in each. That is sensor fusion. It is not a magic vote where 2 sensors shout louder than one. It is a continuously updated estimate of a changing world, with uncertainty still attached. That fusion step is where engineering earns its keep. Different sensors fail differently, which is useful only if the system knows the difference. Once the vehicle has measurements, it needs a usable world model. Part of that is localization, matching its motion and sensor data to the road geometry, closely enough to know which lane it occupies. Part is perception, detecting vehicles, cyclists, people, signals, road edges, and the pieces of the scene that are relevant right now. A good system does not simply draw boxes around things and declare victory. It tracks them over time, estimates speed and direction, and keeps separate the permanent parts of the road from the parts that can suddenly do something interesting. Detailed maps can provide useful context, but a map is not permission to ignore a temporary stop sign. Production reality has a special fondness for temporary stop signs. This is why a self-driving stack needs a model of what it sees and a way to say what it does not see. Pretending uncertainty vanished is not a feature. Prediction is where driving turns from geometry into social inference. The car in front may continue. It may brake. It may cut across 2 lanes because somebody remembered their exit at the last possible moment. A pedestrian near a crosswalk may wait, step forward, or simply be standing there with a coffee and no interest in helping our software demo. The system cannot know intent with certainty, so it considers plausible future paths and assigns them some level of likelihood. This is why an autonomous vehicle should not drive right up to the edge of what it can currently see. Occlusion matters. Uncertainty matters. A model that is merely confident about a hidden vehicle is not safer because it used a nicer font in the investor deck. Prediction does not need psychic powers. It needs enough humility to preserve room for the futures that have not happened yet. Planning takes that uncertain world and turns it into an actual maneuver. The planner asks questions that sound plain but carry a lot of math behind them. Which lane is legal? Is there a gap? Can I slow down comfortably? Will this path leave room if somebody else changes course? The output is usually not a single command like turn left now. It is a short trajectory, position, speed, and steering over a brief future window. A lower-level controller then tries to follow that trajectory through the very unglamorous reality of tire grip, braking limits, steering response, and road slope. This is the split people miss. Choosing a good path and physically executing it are connected jobs, but they are not the same job. But this sounds less glamorous than a single AI steering by instinct. Good. Boring control loops have an excellent safety record compared with intuition on a wet ramp. Now for the phrase multi-agent. Roads already contain many agents in the ordinary sense. Drivers, cyclists, walkers, traffic signals, and sometimes a goose with a more ambitious routing policy than the city planned for. Inside an autonomous vehicle, there may also be specialized models and modules doing different jobs, but cars on the road are not usually conducting a clean little negotiation protocol with one another. Most coordination is indirect. Each participant observes, predicts, follows traffic rules, signals intent where the system allows, and leaves margin for somebody else to be surprising. An intersection is not solved because every car shares a group chat. It is solved because the system can handle incomplete information without assuming everyone else read the same documentation. That distinction keeps the conversation grounded. Cooperation on a road is real, but it is often communication through space, rules, and caution, rather than an invisible digital town hall. Vehicle to everything, or V2X, can add useful context. A signal could share its phase and timing. Roadside equipment could report a work zone. Vehicles may exchange certain safety messages that can make a scene easier to understand. But it should be treated as supporting information, not a permission slip to stop looking out the windshield. Connectivity can be unavailable, stale, misconfigured, or simply missing from the road where the car needs to work. The resilient design principle is familiar from the data center. Use helpful redundancy. Know which input is optional, and fail safely when a dependency is having a personality. The car still needs to perceive the light in front of it and the person walking beside it. Helpful infrastructure can make the picture clearer. It cannot turn a weak fallback into a strong one, and it certainly cannot make every road equally equipped overnight. The safety story is mostly about the awkward cases. Rain can change sensor performance. A truck can hide a cyclist. Construction can redraw a familiar road overnight. A human can make a legal move that is still hard to predict, or an illegal move that arrives with astonishing confidence. No responsible system gets to pretend those cases are edge decoration. It needs operational limits, monitoring, testing, redundancy where it helps, and a way to reduce risk when its certainty drops. That might mean slowing down, waiting, choosing another route, or handing the situation to a carefully defined fallback process. The engineering win is not never encountering uncertainty. It is recognizing uncertainty early enough that the car has options left. At 2 in the morning, a safe system is the one that behaves sensibly when a dependency is late, blocked, or covered by rain. Cars deserve the same standard. The real-world question is not whether a vehicle can complete a polished ride on a sunny route. It is whether a fleet can operate inside a community with clear limits, honest incident reporting, safe interactions, and a plan for the moments when automation is not the right answer. These systems can affect access to mobility, logistics, road safety, city design, jobs, and public trust. That makes the ordinary operations work matter. Map updates, maintenance, remote assistance policy, driverless deployment boundaries, safety cases, and public reporting are not paperwork taped to the side of the car. They are part of the product. If the technical stack is the vehicle's nervous system, operations is the part that decides whether the system is allowed onto the road. That is why the evidence to watch is operational behavior and safety performance over time, not just a neat demo clip with a very cooperative intersection. My night shift verdict: autonomous driving is not one miracle model taking a test drive. It is a layered system that has to sense the world, estimate what it does not know, predict other people, choose a legal and comfortable path, and stay inside the physical limits of a car. AI is part of that system, but it is not a substitute for measurement, safety margins, testing, and accountability. The flashy part is a car moving with nobody at the wheel. The difficult part is the invisible discipline that makes the car hesitate when it should, stop when it must, and leave a trail engineers can examine afterward. Night shifters, what part of that stack surprised you most? The more ordinary the system looks from the passenger seat, the more deliberate engineering is usually happening underneath it. So, night shifters, bring it back to the system, not just the headline. Keep the confirmed mechanics, name the trade-offs, and leave room for the unknowns. What part of this system surprised you the most? If you want the real story behind the headlines, you know where to find me. Stay caffeinated, stay curious. I need to go tend to a backup job that is attempting to become a long-term relationship. Night shift engineer out.